Okay, so after the chain isomers and the functional group positional isomers, we are moving towards the third type of isomers that are known as pos. These are now functional group isomers. Now we need to talk about functional group isomers. We need to talk about functional group isomers. ये functional group isomers क्या होते हैं? Functional group isomers का मतलब ये होता है कि you still have the same molecular formula, but you have different type of functional groups over here. For suppose, if I just talk about this molecule, for suppose I have this molecule which is like CH3, CH2, C double O, CH2, CH3. What is this? This is one of the ester, right? So you can see this. This is actually ethyl, and we have 3 carbons. So it is ethyl propanoate. This is ester, which is ethyl propanoate, and we have 5 carbons over here total, and 10 hydrogens along with 2 oxygen. This is what we have, ethyl ethanoate, which is one of the part of esters, right? These are ester family members. And if you talk about 5 carbon carboxylic acid, so it will be CH3, CH2, 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 C double OH. Now what is this? This is carboxylic acid, and still you can see this. The name of this is 1, 2, 3, 4, 5 carbons. So it is pentanoic acid. This is pentanoic acid, this different family member, right? And you can see this general formula is again C5H10O2, and this is the family member of carboxylic acid. Carboxylic acid say hai iska ताल्लुक. You can see this, the molecular formula are still same, but different functional groups or the member of different homologous series. That is why they are termed as functional group isomers. Is that clear, every one of you? Yes, everyone, is that clear, Bate?
Yes, sir.
Sir, can you repeat it again?
Yes, this is a functional group isomer because they have same molecular formula, but they are the part of the different families. They are the part of different functional groups. You can see this, ester is the different homologous series, and the carboxylic acid is a different homologous series, but still they are having same number of carbon, they have having same number of hydrogens, they have same number of oxygens. That is why they have same molecular formula but different structural formula, so they are isomers of each other. If you are not understanding this part, just look at the example number 2. For suppose if we talk about example number 2, for suppose what we have butene, right? 1 carbon, 2 carbon, 3 carbon, 4 carbon, right? This is for 4 carbons, and this is what, double bond over here. So we can consider this is the part of alkene family. This is the part of alkene family. So this is what, butene. I'm not considering this right now butene because अभी हम but1ene और but2ene वाली बात नहीं कर रहे हैं. but1 और but2 वाली बात अगर हम करेंगे तो वो पोजिशनल आइसोमर्स हो जाएंगे, ठीक है ना? तो अगर मैं इसको फिलहाल अभी सिर्फ मैं इसको ब्यूटीन कंसीडर करूं तो ये क्या हो जाएगा, एक अल्कीन है 4 कार्बन वाला, डबल बॉन्ड बीच में, दैट्स फाइन, ठीक है? उसके बाद जस्ट लुक एट ओवर हियर, व्हाट इज द मॉलिक्यूलर फॉर्मूला ऑफ दिस फैमिली? इट इज एक्चुअली molecular formula of this compound, sorry, this is C4H8, and this is a part of alkene family. That's fine, good. Then for suppose if I have this molecule, this is the closed structure, this is a closed structure, and you can see this, every carbon have single bond, and now to complete all 4 bonds of the single carbon, we require 2 more bonds with hydrogen like this. So this is like one of the compound, and you can see this is closed chain, and but they have carbon single bonds, so they are considered as alkanes. They are considered as alkanes because they have carbon single bond, but as they are closed chain, so we can consider this, they are the part of cycloalkanes. So you can name this compound as cyclobutane. You can name this compound as cyclobutane. But what is the molecular formula of this compound? This is C4H8. You can see this. They have same molecular formula. They have same molecular formula, but they have different structures. You can see this. This is unsaturated one, and this is saturated compound. There is no carbon-carbon double bond. If you put carbon-carbon double bond over here, you can see this. If you put bromine over there, so you will see this, that bromine is going to be decolorized in this. But if you put bromine in this, you will see that there will be no color change. Bromine will stay over there. There is no reaction of bromine with cyclobutane. So these are the two different families. These are the two different functional groups. These are the two different homologous series, but still they have same molecular formula. That is why they are considered as what? They are considered as functional group isomers. Is that clear, Bacho?
Yes.
Then example number 3. Just look at over here. One more example, Bacho. For suppose what we have, for suppose we have this compound. For suppose we have this compound. What is this? This is one of the compound known as aldehyde. This is one of the compound known as aldehyde. This is a part of aldehyde family. And the name of this compound is propanol. This is what? Propanol, right? The molecular formula of this is C3H. We have 6 H's over here and a single O, right? So this is the molecular formula of this compound. This is propanol, right? If we talk about 3 carbons over here, again, I'm just drawing 3 carbons over here, and 1, 2, 3 hydrogen, 1, 2, 3 hydrogen. Over here we have carbon double, or carbon and oxygen double bond, and this is, for suppose, the compound. What is this? This is the family member of ketone, so it is known as propanone. This is what? Propanone, right? What is the molecular formula of this? Again, we have 3 carbons, we have 6 hydrogen, and we have a single oxygen. But this is not aldehyde. This is ketone family. So you can see this, they both have same molecular formula, but they have different structural formula, and also they have different family. They have different functional group. That is why they are considered as functional group isomers. Is that right, Bacho?
Yes, sir.
Yes, sir.
Even you can see in this way as well. For suppose if I just talk about this compound, this is ester. This is ester. You can see this. This is ester. Even in this compound, you can see this. We have one more type of the structural formula of this. For suppose this is what? 1, 2, 3 carbons. This is what? This is ethyl propanoate. This is one of the structure of this. Even I can draw this one as well. What is this? This is also the isomer of this compound. Why this is isomer also? Because you can see this is having what? 5 carbons and 10 hydrogens and 2 oxygen. And over here, this is also having 5 carbons, 10 hydrogens and 2 oxygen. Even the name of this compound is ethyl propanoate. The name of this compound is ethyl propanoate. And the name of this compound, it is actually what? It is propyl ethanoate. It is the propyl ethanoate. So it is also what? Functional. It is also what? Isomer, right? This is simple isomer, but this is actually the position changing of what? Functional group. हमने position towards change कर दी functional group की. This is also isomer. You can even consider esters in this way. This is not a different functional group over here. That is why we cannot consider this functional group isomers. This is what? Changing of functional group, right? So this is what about positional isomers? We can even change the position of ester linkage. And even you can make branch over there as well if you want to. For suppose this is what? 1 carbon, 2 carbon, and like this. And over here, this is oxygen, 1, 2, 3 carbon. You can even draw like this. This is also one of the compound. You can see this, जो कि आपके पास ester है, and again 336, 39 and 1H. This is C5H10O2 again. This is also what? One of the positional isomer of ester linkage. So we have a lot of isomers. We can make different isomers in different forms. So sometimes you will have branch isomers, sometimes you have positional isomers, sometimes you have like branch isomers, position isomers, and sometimes we even have functional group isomers, right? So we have 3 different types of chain, functional and positional isomers that are part of structural isomers. So this is known as structural isomers. They all 3, ये सारे chain isomers हो, चाहे आपके पास पोजिशनल आइसोमर्स हो, चाहे आपके पास क्या हो बच्चों, आपके पास फंक्शनल ग्रुप आइसोमर्स हो, दे ऑल आर कंसीडर एज स्ट्रक्चरल आइसोमर्स। ठीक है ना, इनको क्या कहते हैं, हम स्ट्रक्चरल आइसोमर कहते हैं, और इनकी डेफिनेशन सेम है। इनकी डेफिनेशन हमेशा क्या होगी बच्चों, सेम होगी। व्हाट इज द डेफिनेशन फॉर देम? द डेफिनेशन इज दे हैव सेम molecular formula but different structural formula. You need to keep remember they have same molecular formula but different structural formula. Is that correct, every one of you?
Yes, sir.
चलें, अभी मैं आपको दे रहा हूं एक और फॉर्मूला। फॉर सपोज यू हैव C6H12O2. Just draw the maximum number of isomers of this, and I am just telling you that this is ester, so you need to draw all compounds in which you just have ester linkages. अब इसमें चाहे आप ब्रांच लगाएं, चाहे आप पोजीशन बनाएं, फंक्शनल ग्रुप वाला ना बनाएं कि आप इसको कार्बोक्सिलिक एसिड में कन्वर्ट ना करें, जस्ट एस्टर होना चाहिए, एस्टर लिंकेज होना चाहिए, और देखें कितने आइसोमर्स आप इसके बना सकते हैं। जस्ट ट्राई दिस बच्चों क्विकली। आपके पास 6 कार्बन होने चाहिए, और उसके एस्टर लिंकेज आप कितने बना सकते हैं, जल्दी से ट्राई कीजिए। So if you talk about the fourth and the fifth type of isomers, they are actually the type of stereoisomers, right? This is, you can say that this is the major part of your syllabus. This is the main part. लाजमी पेपर में आने वाली चीज है, ये पेपर में आएगी, आंखें बंद करके इसको प्रैक्टिस करके जाएं, ये पेपर में लाजमी आएगी। You need to solve this. What is stereoisomers? I told you that you need to keep remember the definition of this. First of all, I just need to tell you that we have two types of stereoisomers. One is geometrical isomers, and the second one is optical isomers. These two are stereoisomers, and for both of them, we have same definition. So you can say that compounds having same molecular formula. Compounds having same molecular formula, but over here you need to keep remember, but different arrangement of atom, You can say that different arrangement of atoms or group of atoms or group of atoms, right? So you need to keep remember this is the definition for both of them. If they ask for a chain, functional group, or positional isomers, so you need to say that the previous one definition, which is learned by you in O levels, that they are the compounds of having same molecular formula but different structural formula. That is for chain, functional group, and positional isomers. But if they ask for these two, so you need to say that they have the same molecular formula but different arrangement of atoms. तो आपने याद रखनी है ये दो डेफिनेशन में 5 डेफिनेशंस मौजूद है। चेन का पूछे तो पुरानी वाली, फंक्शनल का पूछे तो पुराने वाली, और अगर वो आपसे पोजिशनल का पूछे तो पुरानी वाली, और अगर वो ज्योमेट्रिकल का पूछेगा तो ये वाली, और अगर वो ऑप्टिकल का पूछेगा तो भी यही वाली डेफिनेशन लिखनी है। डेफिनेशन 2 है, टाइप्स 5 हैं, तो 5 टाइप में अलग अलग तरह से आपने डेफिनेशन फिट करनी है, तो ये याद रखिएगा 2 नंबर की डेफिनेशन आती है। Then let's talk about geometrical isomers first. So if you talk about geometrical isomers बच्चों, तो in geometrical isomers we have 3 things compulsory over there. 3 चीजें हैं आपके पास जो कि आपको फोकस करनी है। geometrical isomers में we have 3 things that we need to discuss. और अगर वो 3 चीजें कोई भी कंपाउंड फुलफिल करता है, then that would show the geometrical isomers, right? और जिसको हम क्या बोलते हैं, cis and trans वाले isomers, ठीक है ना? इसमें cis और trans वाली बात होगी, और ये हमेशा सिर्फ तब हो सकता है जब आपके पास कार्बन कार्बन डबल बॉन्ड होगा। पहली चीज, if any compounds containing carbon-carbon double bond, that means कि यार वो शायद geometrical isomers show कर सकता है, शायद, not confirm। अगर ये है तो ये पहली जानकारी है, ये पहली आप समझ लें कि निशानी है जिससे आप देख सकते हो कि यार ये geometrical isomers शायद शो करता होगा। Then second one, ये जो 2 कार्बन कार्बन डबल बॉन्ड वाले कार्बन हैं, ये जो 2 कार्बन कार्बन वाले कार्बन हैं, कार्बन कार्बन डबल बॉन्ड्स वाले जो 2 कार्बन हैं, इन दोनों के पास एटलीस्ट एक स्पेशी सेम होना चाहिए। इन दोनों के पास एटलीस्ट एक स्पेशी सेम होना चाहिए। दिस इज द सेकंड क्लू कि जिससे हमें पता चलेगा कि यार ये आइसोमेरिज्म ज्योमेट्रिकल शो करेगा या नहीं करेगा। ठीक है भाई, तो एक सब्सटेंस जिसके अंदर कार्बन कार्बन डबल बॉन्ड हो, ये बात होना जरूरी है। दूसरी बात ये कि इन दोनों के ऊपर एटलीस्ट एक स्पेशी का सेम होना जरूरी है। अब चाहे ये कार्बन कुछ भी लगा हुआ हो, कार्बन की चेन हो, चाहे ये हाइड्रोजन हो या कुछ भी हो, एनीथिंग, दे शुड हैव एटलीस्ट वन सेम something which is same for both of them, right? एक ये दूसरा पॉइंट ये हो गया। ठीक है, कोई भी चीज हो सेम होनी चाहिए, दोनों के ऊपर एक एक सेम होना चाहिए। थर्ड वन इज कि ये जो कार्बन कार्बन वाले जो दो डबल बॉन्ड वाले जो दो कार्बन है, उनमें से किसी एक कार्बन पर एक जैसे दो नहीं होने चाहिए। फॉर सपोज अगर यहाँ पर x है तो यहाँ y होना चाहिए, एक जैसे दोनों नहीं होने चाहिए। इफ दे हैव एनी वन ऑफ देम, इन दोनों कार्बन में से किसी एक के पास भी अगर एक जैसे हैं, तो इसका मतलब दे विल नॉट शो ज्योमेट्रिकल आइसोमर्स। सो यू नीड टू कीप रिमेंबर कि ये एक जैसे नहीं होने चाहिए। सो दीज आर द थ्री स्टेटमेंट्स दैट यू नीड टू कीप रिमेंबर। अगर इस तरह की स्टेटमेंट आपके पास आ जाती है, इस तरह का कोई स्ट्रक्चर आ जाता है जो ये तीनों स्टेटमेंट्स को फॉलो करे, कार्बन कार्बन डबल बॉन्ड हो, ठीक है, इन दोनों कार्बन पर एक एक स्पेशी एक जैसा हो, ठीक है, और एक ही कार्बन पे दोनों स्पेशी एक जैसे ना हो, तो इसका मतलब है ये सब्सटेंस फिर आपके पास सेस एंड ट्रांस शो करेगा। और अगर दो एक जैसे एक तरफ रखे हुए यानी ऊपर या नीचे, तो दिस मीन्स कि ये आपके पास है सेस वाला स्ट्रक्चर। और अगर आप इसको डायगोनल में बना के रख दोगे, यानी कि एक CH3 को ऊपर रख दो, एक को यहाँ लिख दो, तो it would be known as the trans structure. It would be named as well with them. इनको हम नाम देते वक्त भी यूज करते हैं। So it is actually cis but 2ene. This is what? This is cis but 2ene and this is what? Trans but 2ene. तो even ये nomenclature में भी यूज होता है, नाम रखते वक्त भी यूज होता है। So you need to remember this. बच्चों, अगर आप ब्यूटीन की बात करें तो हमारे पास एक ब्यूट 1ene भी होता है। If you focus over here, so this is what? But 1ene. This is such a what? This is but 1ene. So you can see this. The first statement is fine. They have carbon carbon double bond. That's fine. The second statement is also fine. That carbon carbon double bond जिन दो कार्बन्स पर है, उन दोनों पर एक स्पेशीज सेम है। That's fine. But the third one is कि एक ही कार्बन पर दो एक जैसे नहीं होने चाहिए। You can see this कि इस कार्बन पे दो एक जैसे हैं, तो इसका मतलब है जब ये स्टेटमेंट को ये फॉलो नहीं कर रहा, तो इट विल नॉट शो सिस एंड ट्रांस आइसोमर्स, यानी कि ये ज्योमेट्रिकल आइसोमर्स शो नहीं कर सकता। तो टोटल ब्यूट 2ene और ब्यूट 1ene यानी ब्यूटीन के स्ट्रक्चर्स अगर आप मिलाएं, तो टोटल यू हैव 3 स्ट्रक्चर्स। Number 1 is but 1ene, number 2 is cis but 2ene, and number 3 is trans but 2ene. Is that right, बच्चों? Other than branch structures. ठीक है, every one of you? All right.
Yes, sir.
Yes, sir.
Okay, so every one of you, can you please tell me कि यार पेंटीन का स्ट्रक्चर बनाना है आपने, पेंटीन के स्ट्रक्चर में क्या आपके पास सारे के सारे पेंटीन के पोजिशनल आइसोमर्स जो हैं वो सारे के सारे ही सिस एंड ट्रांस शो कर सकते हैं, या सारों में से कोई सा भी नहीं कर सकता, या कोई एक कर सकता है? पेंट 1ene है, पेंट 2ene है, इन दोनों में से चेक करें क्या दोनों ज्योमेट्रिकल आइसोमर्स शो करते हैं, या दोनों नहीं करते हैं, या दोनों में से कोई एक करता है। जस्ट ट्राई दिस क्विकली। कर सके। Yeah. So the last one is actually what we have, optical isomers. तो optical isomers को आप कोशिश करें कि आप इसको टेट्राहीड्रल स्ट्रक्चर में बनाएं, और इसके लिए इंपॉर्टेंट चीज क्या है बच्चों, हमारे पास chiral center. Chiral center is what? Chiral center is a carbon having 4 different bond with 4 different group of atoms or atoms. So for suppose if you have carbon, अगर आपके पास कार्बन है, इस तरफ for suppose मेरे पास CH3 लिखा हुआ है, इस तरफ for suppose मेरे पास C2H5 लिखा हुआ है, इस तरफ मेरे पास H है। for suppose मैं इस H को बना रहा हूँ, देखो ऐसे थोड़ा सा C2H5 की तरफ, ठीक है ना, इस तरह। और यहाँ मेरे पास क्या है बच्चों? ब्रोमीन है। So this carbon is actually known as chiral center. क्यों कायरल सेंटर कहलाएगा? क्योंकि इसके 4 बॉन्ड हैं और 4 के 4 अलग अलग आपके पास कंपोनेंट से या स्पेशीज से बने हुए हैं, सो यू विल कंसीडर दिस कार्बन एज अ कायरल सेंटर। ठीक है, अब इसको जब आप इसको ऑप्टिकल इमेज के अंदर, जो मिरर इमेज के अंदर जब आप इसको ट्रांसफर करोगे, तो कोई सा भी एक ट्रांसफर चेंज कर दो। जैसे फॉर सपोज आपके पास ये कार्बन है, ये जो CH3 है, इसकी जगह पर आप C2H5 कर दो और यहाँ पर आप CH3 कर दो, और कोई चेंजेस ना करो, बस इसको चेंज कर दो। ब्रोमीन अपनी जगह लिखा रहने दो, और ये जो आपने H बनाया हुआ ना, इसको आप बना दो थोड़ा सा इस तरफ करके, दैट्स इट। तो ये बन गया आपके पास मिरर इमेज। तो दीज आर एक्चुअली व्हाट? These are actually optical isomers. Is that clear, every one of you?
Yes, sir.
Any
Yes.
problem? You always need to draw them in tetrahedral way, right? You always need to draw them in a tetrahedral way. You always need to show the angle over here. We know that whenever there are 4 bonds, 4 sigma bonds of carbon, there should be 109.5 angles. You must need to show them the angles over here. It's must, right? Right, Bacho?
Yes, sir.
Any problem to any one of you? All clear?
Yes.
Yes, sir.
चलिए, तो आज हम अपना लेक्चर्स को यहाँ पर स्टॉप करते हैं। ठीक है, अगर किसी का कोई सवाल है